So before we get into the details of specific classification methods, let's spend a little bit of time talking about the characteristics of classification, and in particular, how to interpret the results, and also how do we evaluate the accuracy of a particular method. I understand that this discussion may be a little more advanced mathematically or logically, and it may be somewhat beyond the scope of this class, but I think it's really important for you to obtain this all the key concepts and understand the terms of data mining, so you will have a competent discussion when it comes to a data mining issue on your job. So please bear with me, and I'll make this part as easy and straightforward as possible. So if we look at a classification method, it's really designed to assign the value of a categorical binary dependent variable to any observation, right? So if we say that there's a particular observation with one binary dependent variable and a whole bunch of explanatory variable, then we use all the data. We use the large data set that we have, create a model so that whenever we see one particular observation based on a set of explanatory variable, then we say that oh, this particular observation is likely to be positive or negative. So those are the two possible output or values of a binary dependent variable. Then how does the classification method comes up with the two possible prediction, positive or negative? Well, the method doesn't really do that. What the method will do is to assign the probability to every single observation and say that that's the probability of that particular observation to be positive. Okay, and then we have to use a cutoff. The cutoff point may be most often is 0.5 or 50% or higher. And then we say that if the probability is higher than the cutoff, then the prediction is positive. If the probability is lower than cutoff, then the prediction is negative. So let's use an example. So let's say that we want to see whenever somebody walks in the door, we want to see whether this person will be a good candidate for mortgage. Okay, so this person wants to get a mortgage, and we want to make sure that this person wouldn't default. So based on a lot of background information, such as the work history, such as other loans, such as the FICO scores and all that, then the model will build the classification method will build a model so that once we input all of those factors, then it will give us a probability of not defaulting. Okay, so let's say that all of these factors will tell us that this person has a 95% chance of not defaulting. Then we say, oh, so and then we have a cutoff of 75%. Then we say, okay, so this person, it has a positive outcome of being a good a loan customer. So we assign that. And then if the next person who walks in the door, based on his FICO score, based on his work history, and so on and so forth, and then the probability of not defaulting is 40%. Which means that this person has a 60% of default. Then we say, okay, so it's 40%, that's lower than our 75% cutoff. Then the outcome of this prediction method, of this classification method, is that this person is not a good loan candidate. Okay, so the outcome is predicted to be negative. So that's how the classification, that's how pretty much how the classification works. Classification methods work. Well, once we understand that, then we see that we can actually assign every single observation into one of the four quadrants in something called a confusion matrix. The confusion matrix is a very common term used in data mining, so just remember that. The confusion matrix is based on two dimensions. So on the one side is the actual value. So these are the actual whether this person is actually the outcome is actually positive or negative. So for instance, in the loan case, then we say that the whether this person actually default or actually is good a good customer or not. But when we build a model, then we also have a prediction made by the model. So the model may predict this person to be either positive or negative, right? So there's a actual positive or negative, and then there's a predicted positive or negative. Then the confusion matrix put this particular one every single observation into one of those four possible outcomes: true positive, false negative, uh, false positive, and the true negative. So what does that mean? So let's just talk about the first one. So true positive means that the positive observations are predicted as positive. So the observations are actually positive, and then the prediction is also positive. The false negative is when the observation is actually positive, but the prediction is negative. So obviously that's a wrong prediction, right? False positive is when the observation is actually negative, but is predicted as positive. So that is another false prediction. And then there's true negative. So the negative observation predicted as negative. So you can see immediately that these two quadrants, true positive and true negative, are those predictions are made correctly. And the other two, these two, false positive and false negative, are those predictions that are made wrongly. And then there's three common terms that people often use to measure the classification accuracy. It's precision, sensitivity, and specificity. So precision is the percentage of observations that's actually positive among those predicted to be positive. So precision is when you add up all of those predicted positive, and then you take the portion of the actual positive. The other two are actually more important, the sensitivity and the specificity, and those are used a lot more often. So the sensitivity is the true prediction among all those actually a positive prediction that are among all of those actually positive. So those true positive among all of those that are actual positive. So so using again the long example. So when we have a past data set of, let's say, 10,000 people or 100,000 people, and then we say that who actually have a clean history of not defaulting. So among all of those people, using the model that we build, how many of them are actually predicted to be good customers? So maybe 90% of the people that are actually good customers are predicted to become good customer. So that's the sensitivity. The other side of the equation is the specificity. Specificity is when we take all those people who are actually negative, or all those observations were actually negative, and to look at the portion of those are predicted to be negative. So those are true negative among all the actual negative. So again, going back to the long example, if we say that based on all of those people who actually default, so how many of them are actually predicted to default? So maybe let's say that maybe 1,000 people actually defaulted, but only 890 people actually predicted to default. So that's the specificity. So that tells me that the specificity is 89% in that particular case. So the sensitivity measures the true positive among all the real positives, and specificity measures the true negative among all the real negatives. And then there are two curves that are commonly used to measure the classification accuracy. So one is called the ROC curve. The ROC curve is a curve that we draw using the true positive rate against the false positive rate. Okay, so I'm not going to the detail of this curve, but when you look at this, then you understand. Then you can probably guess that our objective is to increase the true positive rate and decrease the false positive rate, right? So if we can find a point where the true positive rate is the highest as possible, as high as possible, and the false positive rate is as low as possible, then that will be the best cutoff to use. So which means that on this curve, this point is the best cutoff. Why? Because at this point, if we use, let's say, about 75%, 76% as the cutoff, then the 75% is a cutoff, then the true positive rate will be 75%, and the false positive rate will be pretty low, probably less than 5%. But if we use any other point as a cutoff, then then maybe we can increase the true positive rate. Let's say here, let's say at this point, the true positive rate is very high, right? Is over 90%. But at the same time, the false positive rate is also very high. It's like 40%. So that's not what we want. We want a point where we can actually maximize the true positive rate and then minimize the false positive rate at the same time. So we pick the point where we can actually use a good cutoff point. The other thing is what we call the AUC, the area under the curve. So if we actually measure the area under this curve, so basically we measure the curve, measure the area here. Let me draw it. Let's see if I can draw that. So all these places, so all these area, so this area under the curve, so that tells how much the model is capable of distinguishing between positive and negative. So the ability for this model to actually separate those positive and negative. So AUC is often another measure that we use to see the performance of the classification accuracy, classification method. Again, the math behind this is a little more involved, but you just have to keep in mind that the ROC curve is very often used to talk about the classification accuracy, and the two main use of the ROC curve is to find out where the best cutoff should be, and also to find the AUC, the area under curve, so that we know the power or the capability of this classification method to actually predict the classification. Another measure that we often used for the classification accuracy is called a lift. Lift is not designed, lift is specifically designed to help us figure out whether a classification method will be able to help to get all of those people that's supposed to be positive by using a portion of the population. So this is not necessarily just a straight measure of the power of the classification accuracy. This is used specifically in cases when we want to know, okay, so we only want to sample a small portion of the population in order to get everybody who's interested in this particular promotion, or we want to just to test out all to find the particular group of students who may be interested in this particular course. So we don't have to sample every one of the student or every one of the potential customer. So if we want to get all of the customers or all of those people who may be positive, right? And the only prediction that we use is the average of the population. Then of course we have to get everyone, because the average tells me that half of them will be right, half of them will be wrong. So in order to get everyone, in order to get everyone that's positive, then we have to use everyone in this population. But if the classification is perfect, then we can actually just look at the characteristic and say, okay, so we know that there are 75% of the people who is going to say yes or who are positive, and then we just use the classification and say we can identify exactly those 75% of the people. So every single person we get will be positive, and then we just have to get to the first 75%, and that's it. So the The random one is this blue line. So basically that's completely random. It's all based on the means. And this red line is based on the classification. So if we actually know exactly who's going to be positive, who's going to be negative, then we only go to the positive. So once we hit all of the people that we know are going to be positive, then we can stop because the rest are all negative, right? So that's when the classification is absolutely perfect. But none of the classification method is perfect, so it will fall somewhere between the random approach versus this perfect approach. So how well how well the classification method will help us pick out those people who are going to be positive is basically the lift, is this green curve between the blue one and the red one. So of course, if the green curve, if the lift is closer to the perfect one, then it means that classification is better. And if it's closer to the random one, then of course the classification is less useful.